Hello everyone, this is AB and I'm coming your way again with Modular Arithmetic. Before I begin, I would like to please ask you to subscribe to my channel and also like my videos and watch any of the previous sessions that you have encountered before. Or if this is your first time, do take your time to go through the previous episodes, especially on the topic we are going to discuss today. And today we are going to discuss modular arithmetic. And the last time we talked about how to form tables of modular arithmetic using the addition operation. So if you haven't watched that video, do watch that video so that you will understand what we are going to do today. So today we are going to treat the same kind of problem. We are going to try and formulate a table, a modular arithmetic table, but this time we are going to use the multiplication symbol, or we are going to use the multiplication operation. So let's take an example and get right into it, shall we? So we are going to construct a modular arithmetic table using multiplication. And modulo 6. Okay, under modulo 6. So let's see how we're going to go about this. Multiplication symbol or multiplication operation and modulo 6. First thing we have to do is that we have to determine the possible numbers that are in modulo 6. And we know that in modulo 6, the possible numbers would be 0, 1, 2, 3, 4, and 5. And so this is what we are going to draw our table with. We're going to put rows and columns which contain the possible numbers 0, 1, 2, 3, 4, and 5. So we're going to start off by drawing our table. So we have our table here. We're going to input our operation sign here. And because it's modular arithmetic, you always put your operation symbol in a circle. So we're going to write the possible numbers in this column and in this row. And then when we finish, we're going to combine them. Okay, we're going to combine them. So we write 0, 1, 2, 3, 4, and 5 in the column, and then we write 0, 1, 2, 3, 4, and 5 in the row. Now we are going to combine each of these numbers using the multiplication symbol, and then we will subject it to modulo 6. And whatever we get is what we are going to use to fill this table. So let's begin with the first element of the first row and the first element of the first column. So 0 times 0. We know that 0 times 0 is 0, right? So now that we have this 0, we are now going to convert this 0 in mode 6. So 0 mode 6 will be 0. Since 0 mode 6 will be 0, remained as 0, and we are supposed to focus on the remainder. So we'll have 0 placed here. 0 times 1 is 0. And 0 mod 6 will be 0. So we write 0 here as well. And you'll notice that indeed all the elements in the row above will be 0 because each answer will give us 0. And when we convert that 0 into mod 6, we will get 0. So you can go ahead and try it to confirm if these boxes will contain zeros. Let's move on to the second column. A similar thing is going to happen because we will be multiplying 1 by 0, 2 by 0, 3 by 0, 4 by 0, and 5 by 0. And when we do all these, we will get 0 in each case. And when we convert each of these answers to mod 6, we will get 0. So we will be able to confirm that these boxes will contain zeros as well. Let's go ahead and fill the other boxes, shall we? So we have 1 times 1, which is 1. And 1 mod 6 is 1. So have 1. Let me write it well. We'll have 1 here. Again, we have 1 times 2, which is 2. And 2 mod 6 is 2. Since 2 divided by 6 will be 0, remainder 2. And we want to focus on the remainder as our final answer. This box will therefore be 2. In a similar manner, 1 times 3 will be 3, and 3 mod 6 will be 3. So we write 3 here. Again, 1 times 4. 1 times 4 will be 4, and 4 mod 6 will be 4. 1 times 5 is 5, and 5 mod 6 is 5, because 5 divided by 6 is 0, remainder 5. So we have 5 here. Let's move on to the other boxes on the row below. 2 times 1 is 2, and 2 mod 6 will be 2. So we put 2 here. 2 times 2 is 4, and 4 mod 6 is 4. 2 times 3 is 6. And 6 mod 6 is 0. Because 6 divided by 6 is 1, remainder 0. So the remainder is always our focus. So we'll write 0 here. 2 times 8. 2 times 4. 2 times 4 will be 8. And 8 mod 6 will be 2. Since 8 divided by 6 will be 1, remainder 2. So we write 2 here. 2 times 5. 2 times 5 will be 10. And 10 mod 6 is 4. You can pause the video and try to fill the table if you wish to do so. Let's go ahead and fill the rest of the table. So we have 3 times 1. 3 times 1 is 3. And I wrote 3 directly because 3 mod 6 is 3. 3 times 2 is 6. 3 times 2 is 6. 6 mod 6 is 0. 3 times 3 is 9. 9 mod 6 is 3. Since 9 divided by 6 will be 1 remainder 3. So let's move on to the other ones. Let me clean this end so we can have more space to write. So 3 times 4 is 12. And 12 mod 6 is 0, because 12 divided by 6 is 2, remainder 0. So this will be 0. 3 times 5 will be 15. 3 times 5 will be 15. And 15 mod 6 will be 3. Since 15 divided by 6 is 2, remainder 3. Let's look at the next row. 4 times 1 is 4. 4 mod 6 is 4. 4 times 2 is 8. 8 mod 6 is 2. Because 8 divided by 6 is 1 remainder 2. 4 times 3 is 12. 12 mod 6 is 0. 4 times 4 is 16. 16 mod 6 is 4. Because 16 divided by 6 will be 2, remainder 4. 4 times 5. 4 times 5 will be 20. And 20 mod 6 will be 2. Because 20 divided by 6 is 3, remainder 2. So we write the remainder here, and that will be 2. Let's move on to the last row. 5 times 1 is 5. And 5 mod 6 is 5. 5 times 2 is 10. 5 times 2 is 10. And 10 mod 6 is 4. 5 times 3 is 15. 5 times 3 is 15. And 15 mod 6 is 3. 5 times 4 is 20. And 20 mod 6 is 2. 5 times 5, lastly, is 25. And 25 mod 6 is 1, because 25 divided by 6 is 4, remainder 1. So we write 1 here. So this is how we perform a modular arithmetic operation and use this operation to formulate a table such as this. It's very interesting to know how this process is done. So the first thing you do is you first write the possible numbers. So if you are dealing with, for example, modulo 2, the possible numbers are 0 and 1. If you are dealing with modulo 3, the possible numbers are 0, 1, and 2. If you are dealing with modulo 4, the possible numbers in that modulo is 0, 1, 2, and 3. And so if you are getting the pattern right, for every modular system, the possible numbers are starting from 0 to a number less than the modulo. So if you are dealing with a modulo 30, you will have the possible numbers to be 0, 1, 2, 3, all the way up to 29. And so that is the reason why in modulo 6 we had the possible numbers to be 0, 1, 2, 3, 4, up to 5. And so when you have the possible numbers, then you form your table with the rows and the columns containing the possible numbers. And then you have your operation in the upper left corner as usual, whether it's addition or multiplication. And then you can go ahead, start performing the operations. And when you perform the operations, you can have your answers, which will then be converted into the modulo. And so this is the table that is complete. And let's try and see if we can fish out a few quizzes or a few questions that might be asked when you have such a table. So let's take this question, for example. Let's say you have a question like this. Find n from the table. If 2 times n is equal to 4. So supposing you have a question like this, we want to find n if 2 times n equals 4. So we want to find a number from the table which when multiplied by 2, or which when 2 is multiplied by, will give a final answer of 4. And in this case, you always start off by doing a trial and error. And so with n, we know that n can be any of these possible numbers. 1, 2, 3, 4, 5, and of course 0. So for each case, we are going to insert these possible numbers into the equation. And then the one that provides us with the final answer of 4 from the table will then be the correct answer for n. So let's try when n is 0. So when n is 0, then we can check 2 times 0 give us 0. And so n cannot be 0 because our final answer was not 4. So let's try again. When n is 1. So when n is 1, 2 times 1 will give 2. So since our final answer was not 4, then 1 cannot be the answer. Let's move on to when n is 2. So when n is 2, we are going to have 2 times 2, and that will give 4. So 2 is the correct answer. Let's move on to when n is 3, because we might have more than one possible answer. So when n is 3, we will have 2 times 3, and that will yield 0. And so since we didn't get a final answer of 4, 3 cannot be a possible answer. Let's move on to when n is 4. So when n is 4, we will have 2 times 4, and the final answer from the table is 2. So since our final answer was not 4, we can cross out the possibility that n would be 4. Now let's look at the final try. When n is 5. When n is 5, we have 2 times 5, and the final answer is 4. And since our final answer was 4, we can conclude that 5 is also a possible answer. So therefore, n is equal to either 2 or 5. So when you put either of these two numbers into the equation above, when you put either 2 or 5 into the equation above, it will be satisfied. So the solution to this equation is that n is equal to 2 or 5. There are many other questions that could be asked from this table, and each of them could yield a possible answer. So you can try and ask questions about the table for yourself and try to find answers to those questions. For example, you can say, well, what is n when n times 0 equals 0? So what are the possible numbers when n times 0 equals 0? And clearly you can determine from the table that no matter the number you put here, you will still get an answer of 0. And so from this, when you work it out, you will realize that n will be 0, 1, 2, 3, 4, and 5. So all of these will be possible answers. So this is how you form a modular arithmetic table, and I believe that you have a clear understanding of the formation of modular arithmetic tables. This brings us to the end of this session, and I hope to meet you another time where we will discuss some applications of modular arithmetic. Until then, enjoy your day, and please don't forget to like this video, comment, and share with your friends. Also subscribe to my channel, and I hope to see you another time as mentioned before. My name is Amy. Goodbye.